So why are there different ways? There are different ways because imagine that you are near a coastline. You're in a grid cell next to land, a dry grid cell, and you can actually make assumptions for the gradient. Here, this du dx, what do you do with it near a coastline? And there are three different ways. I'll show you on the next slides. What this one shows you is, for example, you have a coast on the right, and now you can make an assumption for what do you do with the velocity component v, which is here this green triangle. How do you implement how this changes in the x direction? Because you have a ghost cell on the other side of the coastline on land, and you can make assumptions. For example, if you assume that a zero gradient condition, which means that the ghost cell on land has the same value than the one in the wet grid cell, which is shown here on the left sketch, means there is no gradient of v, and this implies that there is no friction. It's called a full slip condition. You can make the assumption that the ghost cell velocity is always 0, which is shown here in the middle, the sketch. This implies, if you average, interpolate onto the coastline, that at the coast you always have half the value of the v component compared to the wet grid cell. This is called the semi-slip condition. Okay, or you can assume that the ghost cell has the same speed but opposite direction. The opposite direction, it's sort of a mirror image, and this one gives you a no-slip condition, okay, because the average is 0 at the coast. If you think about what happens with the u component, well, the u component is directly situated on the coast and is 0 in this case. So this is all about what do we do with the flow component actually parallel to a coast. Okay, so this is how the lateral friction is implemented. The three choices are full slip, semi-slip, or no slip, and the choice of your viscosity coefficient determines how strong the friction is. Okay, so you learned quite a bit today, don't you?